Hello and welcome to the Silent Science. I'm glad you've chosen to join me tonight or today, depending on when and where you're listening. Before we begin, I'd love to know where in Thruworld are you tuning in from and what time is it where you are right now, whether you're nestled under a duvet, curled up on the couch, or pretending to fold laundry while secretly winding down him. Happy you're here. If you find yourself enjoying this gentle journey through nature's wonders, it would mean a lot if you tap the like button and maybe even subscribe. Asterisk, a world painted by light, there it is again. That flicker of gold in the corner of your eye, that flash of electric blue beneath the leaves, that deep crimson bloom opening just before dusk. You didn't imagine it, it was real. But what if I told you that color isn't exactly what you think it is? We live in a world drenched in hues we name and admire, but rarely question. Why are some butterflies so outrageously blue? How does a single-celled organism glow like a star in the dark? And why do some creatures vanish before our eyes, even when they're staring right at us? Tonight, we're not just admiring nature's palette. We're diving into the physics, biology, and mystery behind every shade you see and some you don't. We'll explore how beetles wear armor made of light, how jellyfish speak in pulses of green, and how even bacteria know how to paint themselves in rainbow hues. Before we begin, ask yourself, what time is it where you are? Are you tucked into bed, wrapped in sheets and moonlight? Or are you out there, walking barefoot on sand, lit up by bioluminescent plankton? Wherever you are, wherever tonight takes you, I hope this journey brings you peace and maybe a little more wonder than you expected. Let's begin. Asterisk, what is color, really? Color, what is it, really? If you asked a physicist, they'd tell you it's just energy, a wavelength, a frequency, a ripple in the fabric of light itself. But ask a biologist, and they'll say it's survival, a warning, a signal, a disguise. Ask a poet, and they might call it magic. So which one is right? Let's start with the basics. When sunlight strikes an object, some wavelengths get absorbed, others bounce back. Those bouncing waves hit your eye, travel along nerves, and your brain interprets them as color. Red, green, blue. Simple enough, but here's where it gets strange. That blue sky above you, it's not actually blue. It's just the way Earth's atmosphere scatters light. Shorter wavelengths scatter more easily. That's why the sky glows blue during the day and orange at sunset. And what about the color you see on a butterfly's wing? Is that pigment or something else entirely? In fact, most blues in nature aren't pigments at all. They're illusions created by microscopic structures, bending light in ways only evolution could design. So next time you see a bird shimmer with impossible brilliance, ask yourself, are you seeing pigment? Or are you witnessing physics dressed up as beauty? Asterisk, pigments, nature's palette. Some colors come from chemistry, from molecules locked inside petals, feathers, and skin. These are pigments, the original artists of the living world. Melanin gives you freckles and tans. Carotenoids turn flamingos pink and tomatoes red. Chlorophyll makes plants green and fuels life on Earth. But pigments aren't just for show. They protect, they attract, they communicate. Take melanin, for example, found in everything from your skin to a bear's fur. It acts like sunscreen, absorbing harmful UV rays. Too much sun without melanin. Damage, cancer, death, and carotenoids. Those vibrant reds and oranges, they're antioxidants, fighting free radicals, boosting immunity, and in birds, they signal health. Only the strongest males can afford to eat enough carotenoid-rich food to grow dazzling plumage. So color becomes currency, a sign of fitness, a message written in hue. But what happens when you don't have pigments? Can you still be colorful? Oh yes, and sometimes those colors are even more magical. Structural color, physics in feather and scale. Imagine wearing a suit made of mirrors, not polished chrome but microscopic ones. So small, you can't see them. But together, they bend light in ways that create color without pigment. That's structural color, one of nature's most elegant illusions. Look closely at a peacock feather. No blue pigment exists there, just layers of keratin and melanin arranged like tiny prisms. When light hits them, certain wavelengths reflect back: blue, green, gold. The same goes for the jewel beetle. Its metallic sheen comes from stacked layers of chitin, like 1,000 microscopic mirrors aligned to perfection. And the blue butterfly. Its wings shimmer with iridescent blue because of nanostructures less than a micrometer wide. Each ridge reflects light in perfect harmony, like a choir of photons singing in unison. But why go to all that trouble? Because structural color is dynamic. It shifts with the angle of light. It dances. It changes. It tells different stories depending on who's watching. And sometimes it hides. Camouflage, hiding in plain sight. Have you ever looked directly at something and not seen it? Not because you weren't paying attention, but because nature itself decided to play hide-and-seek. Camouflage is one of evolution's oldest tricks. It doesn't shout. It doesn't flash. It simply disappears. In the forests of Madagascar, there lives a chameleon that can change its entire body color in seconds. Not just green to brown, but blue, yellow, even bright red. Its skin contains special cells, chromatophores, that expand or contract like tiny balloons, revealing different layers beneath. Underneath those are iridophores, reflecting light in ways that shift hues depending on the angle of view. But the real master of disguise isn't always the one who hides best. Sometimes it's the one who becomes something else entirely. Enter the mimic octopus. This cephalopod doesn't just blend in, it impersonates. When threatened by a predator, it changes shape, color, and movement to resemble a sea snake, a lionfish, even a flatfish. It's not camouflage in the traditional sense. It's performance art. Evolutionary theater. A living illusion. And then there's the stick insect, so perfectly shaped like a twig that it sways gently in the breeze, mimicking the motion of leaves. Some even have lichen-like markings. Others look like thorns, all designed to say, "I'm not here." So what does it take to vanish completely? Is it pigment alone, or is it perception? Think about it. How often do we miss things right in front of us? How many creatures walk among us unseen, not because they're small, but because they've mastered the art of being overlooked? Camouflage is more than survival. It's a silent dialogue between predator and prey. A game played in colors only some can see. Mimicry and deception. When color lies, what if I told you that color could lie? That sometimes the most brilliant hues in nature aren't meant to dazzle but to deceive. Meet the king snake. Harmless, non-venomous, but oh, how it wears its costume well, with bands of red, black, and yellow that look almost identical to the deadly coral snake. The difference? A rhyme. Red on yellow, kill a fellow. Red on black, friend of Jack. But would a predator know that? This is Batesian mimicry, a clever evolutionary trick where a harmless species imitates a harmful one to avoid predation. It's a visual bluff, a gamble that says, "Don't eat meat, might hurt you." But not all mimicry is about safety. Sometimes it's about power. Consider Müllerian mimicry, where two or more harmful species evolve similar warning signals. Like bees and wasps, both brightly colored, both armed with stings. By looking alike, they reinforce the message. Stay away, we're dangerous together. And then there's aggressive mimicry, where predators use deception to lure their prey. Take the female fireflies of the genus Phageurus. They mimic the flashing patterns of other firefly species to attract unsuspecting males and then devour them. Color, in these cases, isn't just communication, it's manipulation. A language of lies written in light. So next time you see a creature wearing bold stripes or bright spots, ask yourself, are you looking at a warning? Or are you watching a con artist in nature's grandest heist? Signaling and courtship. Love in living color. In the animal kingdom, color is more than survival. It's seduction. It's advertisement. It's love dressed in light. Picture this: a male bird of paradise, perched on a low branch in the dense jungle of New Guinea. He spreads his wings, fans his plumes, and begins a dance so precise, so hypnotic, it looks rehearsed. His feathers shimmer like liquid gold. His eyes glow like embers. And somewhere nearby, a female watches. Why go through all this effort? Because beauty matters. Because in the world of mating, color is currency. These elaborate displays evolved, not because they're pretty, but because females choose them. Over generations, the most colorful, the most dynamic, the most dazzling males passed on their genes. And so evolution sculpted not just survival, but spectacle. Peacocks, too, rely on their plumage. Each eye-like paterna marvel of structural color. Each feather a signal of health, strength, genetic fitness. Even cuttlefish, those masters of disguise, use color to flirt. Their chromatophores pulse in waves of red, brown, and gold. One side of their body may flash a courtship display, while the other remains camouflaged, talking to a mate without alerting predators. And in the dark corners of the rainforest, poison dart frogs glow like jewels. Their vivid blues, yellows, and reds aren't just beautiful, they're honest signals. Only the healthiest frogs can produce the most potent toxins. Their color screams, I taste bad, don't touch me, but also whispers, I am strong, choose me. So whether it's a butterfly fluttering its iridescent wings, or a fish flashing neon hues in the deep, color is never random. It's purposeful. It's persuasive. It's passion painted in photons. bioluminescence. Glow in the dark as the sun dips below the horizon. Another kind of color emerges. Not reflected, not refracted, but born from within. Welcome to the world of bioluminescence, nature's own lantern, beneath the waves. Microscopic organisms called dinoflagellates light up with every ripple. Step into the water at night and leave behind trails of electric blue. Touch the surface and watch it shimmer like stars falling into the sea. But why do they glow? For some, it's defense. A sudden burst of light startles predators, or attracts larger ones to chase them away. It's like calling the cops. When someone tries to mug you, deep in the ocean, the anglerfish dangles a glowing lure made of symbiotic bacteria. It waits in darkness, patient and still, then snap. Dinner is served on land. Fireflies blink in perfect synchrony, turning entire forests into living constellations. Each species has its own rhythm, a Morse code of romance. Flash twice, pause, flash again. If the response comes back, right, you've found your match. And in the damp corners of the forest, glowing mushrooms whisper secrets in the dark. Their eerie green light is produced by luciferin and luciferous molecules that react to create cold fire. No heat, just light. A quiet glow that pulses with life. Bioluminescence is not just beauty, it's biology. Chemistry in action. Light, born from life itself. So the next time you see a flicker in the dark, don't be afraid. You're witnessing one of Earth's most magical conversations. A language spoken in photons, written in evolution, and whispered across time. Closing reflection. Drifting through the spectrum. So here we are, back where it all began. Not with answers, but with wonder, with color, and the gentle realization that what we see is not always what is, from shimmering beetle shells to glowing bacteria hidden in plain sight. We've wandered through a world shaped by light, pigment, structure, and perception. We've seen how nature uses color, not just to be beautiful, but to survive, to speak, to hide, to attract, to deceive. Color is language. Color is strategy. Color is life, dancing in wavelengths. And yet, even now, after all we've explored, there's still so much we can't see. Creatures watching us through eyes we can barely imagine. Signals flashing in ultraviolet, infrared, or patterns too fast for our brains to catch. Worlds within worlds, dressed in hues we'll never fully understand. But maybe that's the point. Maybe the mystery is part of the magic. So wherever you are tonight, whether it's morning, dusk, or somewhere in between, take a moment, look around. Let your eyes linger on something small, a flower, a feather, even the way the light hits your window just so. There's more going on than meets the eye. Always has been, always will be. If this journey stirred your curiosity or brought you peace, thank you. Thank you for listening, for letting science tuck you in, and for sharing this quiet moment with me. Don't forget to like, subscribe, and hit that bell if you'd like to join me again next time for another gentle dive into the wonders of the natural world. Until then, I wish you a night wrapped in soft light, drifting dreams, and colors beyond imagination. Good night, traveler. Sleep well. Dream in color.